Hey everyone, in this video what we're going to do is we're going to find all values of k for which the given equation is solvable for real x. Let's begin by multiplying both sides by 5x plus 2. So we have x squared plus x plus 2 is equal to 5x plus 2 multiplied by k, which simplifies to 5xk plus 2k. Now rearranging our equation in the following way, we have x squared plus x minus 5xk plus 2 minus 2k is equal to 0. Notice here that we actually have a quadratic equation with the following coefficients: a equal to 1, b equal to 1 minus 5k, and c equal to 2 minus 2k. Now what we're going to do is we're going to figure out what the roots of this equation are using the quadratic equation. So we have minus 1 minus 5k plus or minus the square root of 1 minus 5k squared minus 4 times 2 minus 2k all divided by 2. Now we're interested in the discriminant here. We want this discriminant to be positive or equal to 0, because if it was negative then we wouldn't have real solutions. So we want to figure out what values of k ensure that the discriminant is positive or equal to 0. So let's look at the discriminant in a little bit more detail. Expanding it, we have 1 minus 5k squared minus 4 times 2 minus 2k is equal to 1 minus 10k plus 25k squared minus 8 plus 8k, and that just simplifies to 25k squared minus 2k minus 7, which is again a quadratic equation with the following coefficients: a equal to 25, b equal to minus 2, and c equal to minus 7. And we can use the quadratic equation in the following way to determine the roots of our quadratic. We have 1 plus 4 times the square root of 11 divided by 25, and 1 minus 4 times the square root of 11 divided by 25. Now, what does this tell us about the values of k that we're interested in? Well, if we look at the graph, or a graph that somewhat represents our quadratic 25k squared minus 2k minus 7, we can see that between our two roots, our quadratic equation takes on negative values. And in the region from minus infinity to 1 minus 4 times the square root of 11 divided by 25 and 1 plus 4 times the square root of 11 divided by 25 to infinity, our quadratic takes on positive values, or it's equal to 0. So what does that tell us about the values of k for which our equation is solvable for real x? Well, it tells us that our solutions can't lie in between the interval 1 minus 4 times the square root of 11 divided by 25 to 1 plus 4 times the square root of 11 divided by 25, because then our quadratic equation would take on negative values and our discriminant could be negative, and that would lead to complex solutions. Therefore, we have that our values of k are k less than or equal to 1 minus 4 times the square root of 11 divided by 25, and k greater than or equal to 1 plus 4 times the square root of 11 divided by 25. Which is the final answer to this problem. Thank you very much for watching. I hope you found this content useful. Make sure to like and subscribe. If you have any questions or problems you'd like to see get solved, leave them in the comment section below. I hope you have a great day.